Thanks everybody to be here. Unfortunately, due to some hardware issue or software issue, I cannot share my camera, but believe me, I'm here, and this is not a pre-recorded talk. So in case you have any questions, feel free to ask them, and I will do my best. I am Nicolas Frankel. I've been a developer or an architect, or well, I've held a lot of technical roles throughout the years. I started working 20 years ago, and I was working mostly as a consultant most of the times. And 2 years ago, I changed my career path to become developer advocate, so I can explore new fun stuff. And right now one of the fun stuff that caught my interest is change data capture. I work for a company called Hazelcast. Hazelcast has two main products. The first one, you probably heard about it, is in-memory data grid. And you can think about an in-memory data grid as a distributed data structure. Instead of having a hash map inside of your JVM or whatever, then you have this hash map that is shared and replicated over several nodes. And so you can keep that and use it for your needs. And the other product, I will talk about it a bit later, so I won't delve further right now. Our agenda is the following. First, that we are all on the same foundation, I will just talk a bit about caching. And then I will list several options to keep the cache in sync with the source of truth that lies behind. And in our case, in this talk, the source of truth will be a database. Then I will talk about change data capture and about Ibsum, which is a very fresh CDC implementation. Then I will describe how Hazelcast Jet and Ibsum can work together. And finally, I will try to have a working demo to impress you. This slide is the most important of the talk. If you remember one thing, it must be this slide is the trade-off. I'm afraid that in our industry, there are a lot of talks of people that say, hey, you must do this thing or you must do that thing. And most of the cases, it's a bit more subtle. And yes, there is always a trade-off involved. And in general, when you suffer from poor performances, your first reflex is to set up a cache. It's perfectly valid. It's the reason you set up a cache. But then the trade-off is you have access to data faster because it now is local, but then the data might be stale. It's a risk that the data is stale. This system is a very simple system, and in that system, the application always goes through the cache to read or to write. And in that case, the cache is always green. The data is never stale. It's just like a facade in front of your source of truth. The application reads from the cache. If the cache doesn't contain the data, it reads it from a database. And when it writes, the application writes to the cache and the cache writes to the database. And everybody is happy. It's just like a fairy tale. Unfortunately, that's not the real situation. Life is much more complex. And in general, what you have is a new component that writes also to the database. And this is fairly frequent, actually. If you think about, probably in your database, you have reference tables. Those reference tables need to be updated every now and then. And it's probably not the job of the application. It's probably a batch that runs perhaps yearly, perhaps monthly, you don't know. Well, you probably know in your case, but there is no hard and fast rule. At least I don't know in your case. Let's say that the data in the source of truth is updated sometimes. And this begets the hardest question: how do we keep the cache in sync with the database? And you might have heard this quote before. There are two hard things in computer science: naming things cache invalidation, and of course off by one errors. And the gist is cache invalidation. And I just want to take some time to like delve a bit on the semantics, because there is cache eviction and cache invalidation. And cache eviction is the fact that your cache is bounded. If you use a professional caching solution, it has bounds, because if you generally, when you start writing your own cache, which I did, like every developer did in the past, we use a hash map, we are very happy, but it's unbounded. So it grows and grows and grows and grows and grows. And well, at some point it takes a lot more memory and your application just starves. So just use a professional cache solution. And now you are able to set a limit on the number of entities. And cache eviction is when the cache has reached its maximum number of entities and you need to add one more entity. Which entity do you remove from the cache? There are several strategies. You have LRU, you have FAU, you have priority. There are a lot of strategies available. And then there is cache invalidation. And cache invalidation is the parameter that when you set an entity in the cache, how long will it be valid? How long will it be there? And that's very important. That's what the previous quote referred to, is what's the correct time? And it's hard actually to think about the correct time. Let's say that your batch in the previous diagram runs like every hour. Now, if you set a time to live that is higher than 1 hour, then there will be updates during this, let's say, 2 hours or a day time span, and you will miss those updates. So you will need to have the time to live that is set at a span that is less than the frequency. But if you have a time to live that is much less than the frequency, actually you will waste resources by reloading data from the source of truth, and the data won't have changed. And this is only if you think that there is a frequency, which in general is not the case. So how can we manage that? We could schedule a polling process. So outside the cache, we have some process that does a job of reading and writing. But again, we need to have a set frequency to have the schedule, and it doesn't work like this. So the only solution is to change our point of view and to start seeing the world by the filter of events. So let's be event-driven. And event-driven fits our use case perfectly, because in that case, if no writes happen, then we don't need to do anything. And as soon as the write happen, then we will update the relevant cache item. So how do we implement event-driven? Well, if you have worked in IT before with database management system, if I tell you, hey, let's do something event-driven, you will probably think about triggers. There are two downsides to this approach. The first is not every database implement actually triggers. Now imagine we have a database that implemented trigger, for example, MySQL, and we need to call an external process. That's a real issue. All triggers, they are actually designed to change the data inside the database. But now here we need to update the cache, which sits outside the database. And so we need to call some process, some script, whatever, to do some cache invalidation, or even better, to update the value inside the cache. So let's take an example. MySQL actually implements those triggers, and MySQL offers this user-defined function feature. So you can actually call something outside the database, which is exactly what we want. But of course, it comes with a lot of constraints. The first is that those functions, they must be written in C++. Probably for most of you, that's fine. For me, I didn't touch C++ for like 20 years. I only studied it, and I wouldn't be able to write a single line of C++, even more so like professional C++. Then the operating system must support dynamic loading, which is not super great regarding security. And then the function you wrote becomes part of the running server and is bound by all constraints. And you can have a couple of more constraints that are less severe, but still. So if you're interested, there is a link, and you can read about every constraint that you need to uphold. Fortunately, somebody was smart enough to create a generic library. So you just need to use this library, and then you've got this exec call, and then you just need to write the command, and it will be executed. So you can think that, hey, it's done. That's we solved this issue. That's one way to look at it. However, this approach has several downsides. The first, as I mentioned, it's implementation dependent. So it only works for MySQL in this version. If you are not on MySQL in this version, then probably you need to find the real way how to do it in your database, and hoping that your current database implement triggers. Then it's super fragile. As I mentioned, there are a lot of moving parts. If any of them fails, you will be in deep trouble. Something that doesn't come at first sight, but which probably will be a maintenance nightmare, is it's bound to break at some point. There will be a failure. And then who will be in charge to debug it or to maintain it? Will it be a developer, the developer who created the function in the first place? Will it be the database administrator? Will it be a third function, a DevOps? Or, like probably it will happen, nobody will commit to maintain that because it's too fragile, and it will be a maintenance nightmare. Also, if you have used triggers in the past, you know that if you've called triggers too frequently, well, they can be very resource consuming. And now we have this new or not so new concept called change data capture. And change data capture seems to be quite new, but actually we'll see there are a couple of implementations that you probably used in the past without using this name. And it is just to say, hey, when there is a change on my database, I just want to be able to track what has changed and to do something with it. And actually, as I mentioned, you probably might have done some kind of change data capture in the past. In general, you were using polling plus a specific column, a timestamp column, a version column, a status column, or like this kind of things. Or perhaps you were already doing it with triggers, but the current way to do that is to scan the logs. And when I say log, I'm not talking about the log file that your developers need to write debug or info or error. I'm talking about something that is very it's an implementation detail. So you might know about this famous article from Martin Klempeter, turning the database inside out. And in that article, he uses this concept of a DB abstraction. When you, as a user, you execute a query, you make a select or an update or whatever, you don't care about actually the architecture inside it. This is an implementation detail for you. In general, your DBA or your ops team will probably have set leader nodes and then many followers, in case just the leader suffers from a breakdown, because it will happen at some point in time, and then your system is still up because a follower will catch up. How does it work? Well, every time your leader receives a change event, an update, a delete, or an insert, the first thing it does, it will write it in a specific file on disk. And this is the log itself. And when the leader process fails, that's not an issue. The follower will catch up, so it will read the bin log, or the log, sorry, the bin log is an implementation of MySQL. It will read the log, it will replicate the results, and it will be up to date with the latest changes. Even if you don't have a leader-follower architecture, if the leader fails at some point and the process restarts, it will be able to catch up with the change because they have been written in this log file. And this log file is append only. And as a user, this is for you an implementation detail. You probably never see that. It has two use cases, as mentioned. The first is replication, and the second is data recovery. Replication is in the case of primary and follower nodes, and the data recovery is if you have only one node. And so this log contains every event that affects the state of the database. It can also contain all what is considered DDL, so when you create table or update columns or whatever. And so the idea is of this last implementation of CDC is, hey, what if we hacked the log? And there might be some reason why it might think not so a good idea. So here is a sample of the MySQL bin log that I have copy pasted, and you can already recognize some stuff. Update test.t where blah 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 set blah blah blah, and a lot of stuff that is completely MySQL dependent. And well, as a kind of reminder, we get back to our issues with the previous solution. It's implementation dependent. It's very fragile. Like if the next version of MySQL changes the implementation, we will need to redo everything. And who will maintain and debug it? It's a tremendous effort. Really, it's a lot of effort. But we have something called Ibsum. And Ibsum actually does all the heavy lifting for us. It's a Java-based abstraction layer for CDC. It's provided by Red Hat. It's licensed under the Apache 2 license. The issue with Ibsum, at least for me, is it's very skewed toward Kafka. So the Ibsum works like that. You have your databases, and then you have your Kafka clusters, and then you have your connectors that are configured to catch and read the event logs, and then they will create items in your topics for you. Of course, everything is configurable. So if you receive one event, you can write to multiple topics, or you can have multiple tables and they write in the same topic. I mean, everything is configurable. But the main thing to understand is they are meant to write to Kafka topics, which can be a good thing if you are already using Kafka, or might not be a good thing if, for example, I just want to update my cache, because then I will need to write to disk and I will need to read from disk, which is not super efficient in this use case. But still, it has a lot of benefits because you only manage to use this abstraction API, and underneath you have plugins or connectors or drivers that know how to talk to a specific database. And this is not handled by you as a developer. This is handled by the Ibsum project. And you already have a couple of drivers that are production ready, such as MySQL or Postgres or even MongoDB, and a couple of others are already incubating. So for example, Oracle, or even DB2 if you are still using a DB2 system. Now, how do we leverage that inside of Jet? So as I mentioned in the first part, Jet is a stream processing engine. By nature, it leverages the IMDG, so it's fully distributed, it's fully in memory. It's also licensed under Apache v2. Of course, like every product company, we have an enterprise offering, but that's not everything that I show you in this talk is completely open source, and you can use it right now. And how does it work? Well, it's a stream processing engine, so we don't reinvent the wheel. You have data sources, you have data sinks, and then we can read from the data sources, do parallelized computation. We can distribute them over the network. We can aggregate data items. We can, well, classical stuff, and then we write them in our sink. We have two deployment models. The first deployment model, if you're a Java developer, is the easiest one. You just use the jar, because by default, Jet is a jar. You use it as a library, and it becomes part of your class path. And to start a new node, you just call jet.new jet instance. And by default, the nodes, they will broadcast over the network. They will find other nodes, and then they will form a cluster. This is very good when you start, and it might even be good for production, depending on your usage, but there might be two downsides to this approach. The first downside is, since the Jet node and your application run into the same JVM, and probably they have different needs, the JVM needs to be configured for one or for the other, or in a more generic way, but then you won't use the JVM to the fullest. And the application and the Jet cluster, and the Jet node, sorry, they will compete for the memory, they will compete for the resources. So that might not be so great. So in general, what you do after a while, when you start having a lot of data, is you have a dedicated client-server architecture. So your Jet nodes, they run inside of Docker containers, for example, or they can just run as jar as you want, but in general, it's easier to run them as containers. Then you can configure the JVM accordingly. And then you can have your application that only embeds the client API. As an added advantage to this deployment model, you don't need to use Java now. We have different client APIs such as C#, Go, Node.js, Python, and C++. And it's the same. You just change the API that you are using, and then you join the cluster as a client. Jet has concepts which probably are the same in every stream processing engine. On the left side, you have the pipeline. The pipeline is the declarative code, so where you will be reading from, what transform you will execute, and where you will be writing to. And then you write that code, and then you have a client that takes that code and pushes it to the stream processing engine. And it's the job to the stream processing engine to read the code and to execute it, to distribute it over the different nodes. And then it becomes a job. Now I think that we have all the pieces that we need. We have still our application that reads from the cache. We still have our database, and we still have this like strange component, whatever it is, that change the underlying data. What we will add is just a Jet job that will read from the bin log, because I will be using MySQL in the demo, and that will get the events, get all the change events made by the XYZ component, and then propagate the new value to the cache. And so in that case, the cache will always be evergreen, which is exactly what we want. So now it's time for a demo. And if you have any question, feel free to ask them. As I mentioned, it's better if you not get stuck on the question. So, sorry, I was too fast. I was thinking two things at the same time. So here I have this application. I will close everything, close all. I have the application and I will just run it. It's just a Spring Boot application, nothing fancy. I don't know if you are Java developers, but I mean, I'm just having this Spring application. I'm not using a Docker file. I'm using Jib to create a container out of it. And I will just show it to you because it will be easier. I have this demo application. Right now, I run it with not MySQL. I run it with H2, which is an in-memory database. It's just to show how it works. here. So I have like 3 entities, and I can show them to you. They were created by Spring Boot automatically at the beginning of my application. John Doe, Jane Doe, John Rue. And I can update one row, and then it will reread the whole bunch. I can show you the code as well. So here, the most important part is the person repository. And the person repository embeds 2 caches, 2 hash maps. And in the first one, I will have the query as a key, and here the query is always the same. It's a select ID, first name, last name, birth date from person. And when I want to read from the cache, I will check, hey, does this query already has some like value? If there is nothing, then I will execute the query on the database. And then for each entity that I return, I will put it into an entity cache. And then I will put the query and the keys that I've returned in the query cache. Otherwise, I just get the keys from the query cache, and then I read each entity cache directly. And when I save, I just put the entity into the entity cache, and then I update the underlying database. So nothing fancy, nothing very hard. And meanwhile, I have a Docker Compose file, which consists of the following. I have my application that I have Dockerized through Jib. I have the pipeline, and I will show you the pipeline afterwards. And I have the database, which actually is the MySQL database. So I will start. I will do this Docker Compose. And the first thing that I will do is I will disable the pipeline, because I want to show you how it doesn't work without the pipeline. So here I will Docker Compose stop the pipeline and check that the pipeline has actually stopped, which is good. And now I get back to this application. Now it's not the local anymore. I'm checking the Docker Compose stuff. And if I update it, Johnny, it still works, and Jenny, and it still works. Now I want to emulate the fact that there is a component that changes the underlying data. So I have created another application that I call update application. It's a very, very simple application. It's this JShell application, and this JShell allow me to do 2 things. The first one, I can list the entities, and here we can see Johnny and Jenny because they're already in the database. And the second is I can update some entities. So I will update the 3rd entity with first name Robert. And now if I list from the database, it tells me, hey, it's Robert. But now the issue is my database, my application is reading from the cache, and it still thinks it's John. That's not what I want. So I will run my pipeline that I have prepared. So I will start it. There is no way with Docker Compose to only start with some of the services. So I need to start everything and then stop the pipeline and then start the pipeline again. It's not comfortable, but that's how it works. Meanwhile, we can check the code, and that's the most important part, the update cache job. And as I mentioned, here is the pipeline. I named it pipeline accordingly. Here is the stream source. It's just configuration. That's the just configuration. It takes a lot of lines of code, but it's just configuration. And then I have the function that transform a Debezium change record into a person. And I have a function that transforms this person into a map entry, because in my cache is just a map. And then the pipeline itself is like actually these shorts. I read from the source, I write it in the log, and then I map what I read to a person and then to a map entry. I mean, it reads very, very like clearly like English. And then I write the results back into the entities cache. Now the pipeline has already started. The very good thing is that at this time, the pipeline not only has started, but it has caught up with the change that I made previously, because the cursor is at the beginning. The bin log is still there. So if I refresh here, I have Robert that is already here. I didn't need to do anything. It has caught up with the latest changes. And of course, if I continue making changes, then of course it will still do them. So I will update to I don't know, Clara. And then of course here I have Clara immediately. So this is an evergreen cache, and this is in a few lines of code. This is not like rocket science. So as a recap, in this talk, I've shown you several stuff. The first, as I told, is the most important stuff, is a trade-off. Every decision has trade-off. So when you use caching, you want data fast, but you accept that it might be stale. If your application is the only component that reads and writes from the cache and the underlying database, that's fine. Your cache will always be in sync. However, in a lot of cases, that's not the case. There will be some components that will update underlying database, and then you will have issues being in sync, and it's very hard to find the correct frequency of polling, of refreshing the cache, or the TTL. In that case, you should move to an event-driven architecture. And regarding event-driven approaches, I listed several of them. So far, the most modern and the one that works pretty well is change data capture through Ibsum and through Hazelcast Jet. So thanks a lot for your attention. I hope you like this talk. I hope you like the demo. You can read my blog where I publish weekly articles. You can follow me on Twitter. If you want to understand more about CDC, because it's only a small slice, you can read the CDC tutorial on our JetStart website. And more importantly, if you want to check the demo by yourself, this is on GitHub. You can clone it, you can use it, you can reproduce it. And I hope that it was okay. And now, are there some questions?
Does it allow an update applied in cache to be synced to DB?
Yes, but that is much easier because so you want the DB to be all, I mean, if I understand correctly, which might not be the case because I'm not a native speaker, you want the database to actually be your derived data and your cache to be the source of truth. That's another way to approach it. That's perfectly valid. But then you have a couple of other issues. Again, it's all about trade-offs. If you make the cache your source of truth and the database the derived data, then you will need to wait for the writes to the database to have completed, because otherwise you might have made changes to the cache that were not yet replicated, and then the database is down and then it's bad. So you lose a lot of performance. No, you lose all benefits of the cache. So the synchronous approach, let's say, oh, I need to wait until the database has written everything and has told me that it's good to have finished, then you lose the benefits of the cache. You better just like read and write to the database directly. You could say, oh, but that's not an issue. What I will do is I will interact with the cache, and then there is an asynchronous process behind, and this asynchronous process doesn't block, and it's right to the database. That's also perfectly valid, but in that case, you might run the risk of losing data, because there is some data that your app consider is okay, is valid, has been written, but it has not been written yet, and then your database crash, and it's not an uncommon occurrence. So there are a lot of again, it's a world of trade-offs. So there are a lot of of possibilities, of options, but every one of them has issues. And here, the one that I mentioned, the only issue there is, which might be a big issue depending on your use case, is this slight window of unsynchronization, the time it takes to process. Now, the goal is to make this window as small as possible. And if you do everything in memory, then it's much, much faster.
Great.
I hope I answered the question.
Yeah, Rishi, if you want to ask, over voice, just let me know. I can unmute you as well. And that goes to the audience. Like if anybody sort of typing it in, you want to just ask, let's send a message and then I'll sort of open it up. The one question from Shankar is, do you have to customize how Ibsum has to save the database history? Because the default behavior is save in a file or in the Kafka topic.
Yeah, that's taken care of by Jet itself. So we use Ibsum internally. You don't need to interact. Well, you won't interact with Ibsum. As I can show you the code back again. The only thing that you need to do is actually to just here is to configure. So here is a configuration, but here, this is just Jet stuff. This is just Jet stuff. So you don't interact with Ibsum at all. You don't interact with Kafka at all. Everything is made for you. This is change record is not a Ibsum class. It's a Jet class. So you are completely shielded from the Ibsum itself. It's an implementation detail.
Very good. The next question from Dasarathi is, do we update query cache and entities cache transactionally?
No, and not at all. That's one of the problem. Well, when you want to be in sync, you might want to decide that it's better to do that transactionally. But every time you do a transaction, actually you are blocking. So here, for example, I'm just like writing it into a sync, and if it doesn't work, I have no way. Well, here I didn't write it, but you could retry multiple times until it works or whatever. That's up to you to decide. If you put locks in place, because one way to do transaction in that case, there is no transaction manager that I know of that could work in different cases, in those different cases. So you would need to implement that yourself, to use logs yourself. That's possible. Again, then there is a trade-off. You want to be as fast as possible, but if you put locks in place, you will be blocking. So you will have consistency at the cost of speed. And in this scenario, you are using cache already because you want to be fast, and you say, okay, I might lose a bit of consistency in order to be very, very fast. So this is possible, but I wouldn't advise it.
Okay. I have one more question. What's the rough timeline for Oracle compatibility?
I have no idea. I will be very frank with you. I have no idea. You need to subscribe to the Ibsum mailing list and check for yourself. I'm not part of the Ibsum team, actually, so I cannot tell you that. The reason I use MySQL was, well, because it was already available, and also I don't need to pay a license.
All right. Audience, I think that's all the questions I see. Nicolas, did you have any closing comments?
Again, I'm very happy you spent this time with me, especially with the competition I had. And if you start having question, or if you thought it over and have a new question, or you were too shy, be sure to ping me on Twitter or join our Slack, and we will be very happy to help you in your path to JET. Thanks a lot, everybody,
Awesome.
and enjoy the rest of the conference.